Okay, Advanced Algebra 2. This should be, I believe, Wednesday the 13th. And today we are going to use, or we're going to look at Chapter 9, which was rational functions. And remember, whenever you hear the word rational in a math class, you should be thinking fraction. So you see how we got a fraction down here. And more importantly, we've got a fraction that has a variable in the numerator and denominator. Okay, so we're going to look at, try to remember how we graph those in Chapter 9. We graph those, if you remember. Let's see here if I can give you some hints. Do you remember dog fences, how dog fences work, and how a dog runs along that dog fence because he learns where it's at and he won't touch across the dog fence because he gets shocked? Well, that's what we did in this chapter. We found those dog fences, okay? If that reminds you. We actually did a three-step process. The first thing we did was we found something called the zeros, or the x-intercepts. That is, where will this thing touch the x-axis? Well, that would be wherever it is equal to 0 at. Now, if you can remember, whenever you have a fraction, when is a fraction equal to 0? It's equal to 0 when the numerator is equal to 0. So to find our zeros, our x-intercept, all we do is take our numerator, which is 2x plus 6, set it equal to 0, whatever our numerator is. Set it equal to 0, and we solve it. And we get x equals -3. So let's come over here to our graph. And -3, 1, 2, 3, -3. So it's going to touch our x-axis right there at -3. And what's important about that is that's the only place we will touch our x-axis. Then we found those dog fences, and the first one we found were our vertical dog fence, and those are called asymptotes. So the other thing to remember about a fraction is you can never let the denominator of a fraction be equal to 0 because that's undefined and you don't have an answer. So if we have x plus 2 in there, then what that means is if we set that equal to 0, we can never let our x be equal to -2. So how do we do that? We make it a vertical asymptote. Vertical runs up and down. So at x equals -2 right there, we'll have a dog fence. Okay, we will not cross that line. Then the other type of asymptote we could have is a horizontal asymptote. And there's three things you got to worry about with horizontal asymptotes. So let's look at what we have. We have what we would call equal weighted. What's that mean? We have a 2x to the first power in our numerator and we have an x to the first power in our denominator. I only look at the highest powers. Those are equally weighted. So what do? We make a fraction out of the coefficients. So we would have a horizontal asymptote at y equals 2. So let me go put that in and we'll talk about the other cases. Y equals 2 is running right there. Now the other possibility as far as is we could have a bottom heavy. That would be like if we would have had 2x over x squared. So that's x to the first, x squared, that's bottom heavy. When that happens, that's automatically at y equals 0, which is your x-axis. Okay? And you could also have top heavy. So if we would have had 2x squared over x, we're top heavy because it's an x squared over an x to the first. When that happens, you do not have a horizontal asymptote. Okay, those are your three cases. Now let's sketch our graph. Well, one thing we know about our graph is, so where's the dog running at? Well, one place we know it's running is down here because that's where it touches the x-axis. Now, how would it run? It would run down the asymptote, getting closer and closer. And it would run west here along that asymptote, getting closer and closer. Never touching the asymptote. Now, that has told us what's happening on this left side of this vertical asymptote. What's happening on the right-hand side? Where's the dog? Is he up top up here or is he down below? How do we figure that out? Well, we have to take a point close to our asymptote, which would be -1. And we have to go plug it in. So let's do that. We'll go up here up top. So we're going to plug in a -1 and see what happens. Plug -1 into our function. So that would be 2 times -1 plus 6 over -1 plus 2. That gives me -2 plus 6 is 4. -1 plus 2 is 1. I get an answer of 4. So that tells me my One point I know my dog is at is -1, 4, which would be right there. So that dog's up top. And what's he doing up there? He's running up that asymptote and along that asymptote, and there we go. Okay, so you have homework problems where you have to decide, you have to find them one at a time. You have to find your x-intercepts or your 0. Remember where that came from. That came from the numerator, equal to 0. 2x plus 6 equal to 0. Vertical asymptotes come from the denominator. When is it equal to 0? Horizontal asymptotes, you have to look at the weighting, okay, and decide and figure out which one of the 3 options you have. Another thing we did in this chapter was simplify rational, if I can get to it here, what's going on? There we go. These rational expressions when we multiply them. Remember when you do this, when you simplify, these are fractions, okay? When you simplify, let's say we had 5 over 7 times 3 over 10. What simplification could we do there? Well, we could do the 5 and the 10 and get a 2. Okay, now what you're doing is you're taking this 10 and saying, hey, that 10 is 2 times 5. And then you're allowed to cancel those common factors, one in the numerator, one in the denominator. Okay, so when we see this x squared minus 9, we got to think of that as x plus 3 times x minus 3 over that x plus 5. Now we're multiplying by, and then what can we do with x squared plus 6x plus 5? That's x plus 1 times x plus 5 over x plus 3. Then if we have a common factor in numerator and denominator, like these x plus 3s, those x plus 5s, we get to cancel them. And our final simplified version of this is x minus 3 over x plus 1. Okay, so break things apart before you cancel anything. Don't you dare, let me see here, don't you dare, and I'll yell at you when I grade these if you do this, don't try and say I'm going to cancel 5 and 5. Can't do that. That's not a 5, that's x plus 5. This one up here is x squared plus 6x plus 5. You got to break them apart first. And what else could we need to know? Well, what would you do? Anybody tell me what we do if this was a division? You would do the exact same thing, only you'd flip this and then start canceling. Okay? So your homework is, don't know if I have it in this video or not. Okay, your homework will be posted and you can submit your homework picture again like usual. And one more day down. See you tomorrow.